Never mind. I'll just record after school today. Okay, never mind. It's over. Okay. So, chapter 6 is titled The Environment and Change Over Time. So, these orchids look the way they do because it helps them thrive in their environment in some way. So, if you could, in Google Classroom, open up your chapter 6 active notes. And so, we're going to discuss fossils. We're going to spend 2 days on fossils. Actually, the rest of the week we'll just spend on fossils. And then on Monday, we'll talk about the theory of evolution and Charles Darwin and how things change over time. That's what evolution is. It's just change over time. And then the final section talks about the evidence for evolution, which is just, again, change over time. So the fossil record. We know that species have changed over time based on the fossil record. And so a fossil is the preserved remain or evidence of a once living organism. Maybe you have stumbled across a fossil. I don't know. Maybe. What?
A leaf fossil.
A leaf, like a leaf that just fell from a tree? No, because it's not preserved. Because it can like break down. So this is something that's like sturdy. So we'll talk about 5 different types of fossils.
In the cement.
Oh, in the cement, like an imprint? Yeah, that's a fossil.
Someone who was dead, but then they weren't dead because they like resuscitated themselves. I don't know how.
But then they're alive, so then they're not a fossil.
They were a fossil because their heart was done beating, right?
Okay, but they weren't preserved.
Yeah, I guess. Those handprints and footprints in the sidewalk, would that be one?
The what?
Handprints and like footprints that people put in the sidewalk?
Yes, those are fossils.
Oh, yeah.
Those would be considered fossils. Trace fossils. So all the fossils that have ever been discovered on Earth they're called the fossil record.
Oh,
Okay? And the thing we want to draw your attention to is number 4. The fossil record is incomplete. It will never, ever, 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 ever be complete. Why do you think that is?
Because we're not immortal. A lot of people are going to continue to die. A lot of things are going to continue to die.
Okay, so it's like continuous. So you're going on like, fossils can always be made. But what about fossils in the past?
I don't think they break down. So.
You don't think they break down? But they can be destroyed. I mean, I could take my fossils and break it, right?
Still be part of the fossil.
Say what?
Still be part of the fossil.
Okay, well, what if I like pulverized it with a sledgehammer?
Just stick it right in like a
Dust.
stormtrooper blaster.
There we go, stormtrooper blaster.
It was wrong.
Is our Earth, our planet, active or inactive?
Yeah.
It's active. What are some events that happen, some natural events that happen on planet Earth?
Volcanoes.
What? Volcanoes, what'd you say?
Oh,
Did you say
like
heat
the
wave?
Yellowstone volcano?
Oh, a meteorite, yep.
We're not in the kill zone.
We're not in the kill zone of the super volcano.
Yeah, it was
Oh, that's nice to know, but we're still gonna get covered in ash.
yeah, if they nail it down.
You know the fun stuff.
Yeah, and all the other fun things flying through the air that just might land. No, I'm just kidding. Okay, so Earth is active. We have volcanoes. We have earthquakes. The plate tectonics, the plates that make up Earth, because our core is active. So you're going to learn this next year in science, Earth science. So our plates, they meet. When they meet and they move, earthquakes occur, volcanoes can occur. Sometimes plates go underneath another one, and then they get melted into magma, so they can bring fossils down with them and destroy fossils. So our fossil record is incomplete. It will always be incomplete. And also, fossils are mostly in the ground. Can we dig every square inch of the ground on planet Earth and you know what I mean? Like you can't find every single fossil that's on Earth.
Because like a fossil could be under a house. And you can't just go barging in the house and go I need to dig under this house.
That's true.
I need to remove your house. We need to dig in this land.
So scientists, they use what they find, or the fossils that we do know of, and based on those fossils, we know that some organisms are no longer around. I'm really thankful dinosaurs are no longer around on planet Earth.
You don't want to
Because there's no way we would be where we are as a species for human.
You don't want a T-Rex to roam in your backyard?
Absolutely not. Okay?
You don't want a pterodactyl to fly in for supper?
No.
I think going to school would be the worst place to go because then the dinosaurs would be like,
Okay.
oh, look at all those humans.
Okay,
I have a book.
this is
I'm
why we
bringing
have
the book.
this.
It's about a dinosaur who went to school.
I think I've read that book. It's cute.
It's like the really long necked ones.
Oh,
And
never
like
mind.
it would like bring kids for rides to parks on his
Oh.
neck.
So fossils help scientists figure out what species that no longer exist looked like when that organism was alive. So like those picture, I mean, no one has an actual picture of a dinosaur.
Click. I
Okay,
went back in
we
time.
have illustrations and, you know, that's to our best knowledge, what we think they may have looked like based on the bone structure.
What if they
Jared.
were neon colored?
So like when your dog's buried, is that a fossil after a long time?
If the bones are preserved, yes. Yep. So, fossil formations. Most fossils are formed from the hard parts of that organism. So bones, teeth, shells. Those are great examples of how fossils can form. So in this picture here I have today's Homo sapien and then an ancestor of us. So you can see that the cranial size has drastically gotten larger over the last 100,000 of years. Saber-toothed tiger, okay? Really thankful those cats are not around.
What? No, you don't want to
Okay.
that.
Nope, absolutely not.
Wait, what?
A saber-toothed tiger.
But Sid the sloth, I mean, man, he would
Oh,
be-
look at this, a pine cone.
Oh, what about Manny? All those guys. You know what?
I love that series. That's a great. Is that the word I'm looking for? Series? It's not a series. It's
It's a movie. There are a bunch of
a
movies.
series of movies. Yeah, the canon, the Ice Age canon, the saga. I don't know.
I have a pretty funny joke that reminded me of shells. So let's say a snail and a slug were dating, and they got married and they broke up. The snail was the female and the slug was the male. The snail's name was Shelly, and the slug's name was Todd, I guess. And they broke up. Todd says to his buddy, "Yeah, Shelly took the house."
Wow.
Wait, I don't get it.
Because she has a shell, and the shell is her house, and she took the house. That was great. Okay, so I'm going to go through 5 different types of fossils, and the first one I want to talk about is mineralization. So this occurs when the organism gets buried under sediments, and the sediments could be mud, sand, dirt, whatever, soil. And there's a body of water associated with it, and there's minerals floating around in this water. And the minerals replace the living tissue. So now the organism that was dead, that's living tissue, becomes mineral, aka rock. So the organism becomes a rock. Does that make sense? Okay, so the minerals come in, replace the tissue, and form a rock. So here are some examples of mineralization, okay? We see this with shells and bones, but wood can also become mineralized too. It's called petrified wood. Now I'm going to see if they're unpetrified, so I can pass them around. I mean, but they're petrified, so they might be a little scared, okay? So just be gentle with them. That was a joke. Okay.
So funny.
So as you can see with these samples, I mean, this looks like a piece of wood.
But it looks like it's rock hard.
It is, and it's really heavy. Okay, wood is light. These samples are very heavy. So you're like, oh wow, look, looks like wood. So I'm gonna pass these around. Feel free to just, look at them and then pass them on to the next person.
Did you poison them?
Yeah, that's why we're
Absolutely, COVID.
Just like your
That's why she's still
Okay,
alive.
everyone use the hand sanitizer. No, I'm just kidding.
My dad has a piece of petrified wood.
What if someone
I think
dropped?
he got it when he was in Iraq or
Hey, you're the
overseas.
second person. You want to know who the first person was?
Oh.
Jeff.
Jeff did what?
Is some-
Nothing. He was just asking me, what would happen? And I'm like, I would just be really upset. I would be very disappointed.
If
But
what?
what would have happened really?
It's like, what did you want me to say?
That's what he's doing his lunch. What about what if? Either it's just gonna stay alive and be one piece, or crack, or break.
Okay, so mineralization. The organism becomes a mineral / rock. It turns into a rock. Okay. next one's called carbonization. So this occurs when the organism gets compressed over time. And under that pressure, it drives out the liquids and gases, and it just leaves a carbon skeleton or a carbon film. So that's called carbonization. So you can see up here we have a leaf that's been, it's been pressed, the liquids and gases are gone, it leaves the carbon film. This fern, this type of insect kind of looks like a wasp or a bee of some sort. So I do have, I think, 2 pretty good examples of that. So this one classifies as carbonization because you can see there's dark imprints on it. But you can see it's a plant of some sort, some leaf, okay? This one is by far my favorite carbonization example. So you can see it looks like some algae or some kind of fern, but then just follow it. Turn it over, you can see it's a continuation. So it's like a 3D stuck in there. I think it's awesome. Rocks rock. So that's carbonization. All right. The third type is classified as molds and casts. So a mold is the impression. So you lay down some new cement, you're like, woohoo, I'm gonna put my hands in there. That's a mold, right? It leaves your imprint. Or maybe you've seen it on sidewalks or people walking across cement. When they laid down the new driveway for the school, someone walked across it. I think they repaired it.
So
Maybe
this
it's still
was-
there.
This was wood.
Yes, it was wood.
Isn't it technically still wood?
It looks like an inside
It's
of
rock
a cave.
now.
Like that.
Yeah, we'll just form a big pile.
Well,
So molds are impressions. Now cast, after the impression gets filled, it forms like a 3D shape of it, and it almost looks like a copy of the fossil. So maybe in your notes, cast is like a fossil copy. Cast starts with the letter C, copy starts with the letter C, it's like a copy of it. I have a lot of examples for casts, okay? I would, in your notes somewhere off to the side. Here we go. So here I have some type of shell organism and it's 3D. These are examples of casts. They actually almost look like the organism. Yep.
That's fake, right?
No, that's real.
How? Looks like it was drawn on.
It's not. I assure you it is not.
Did you buy it from Amazon or something?
No.
she found it in her backyard.
No, I didn't find it in my backyard, but I did find it.
Where else would you find it?
Now, a mold is an imprint. Okay? So this is an example of an imprint. You can see that, again, it was some type of aquatic,
Actually, it looks like.
I don't know, coral. This almost looks like coral to me,
Wait,
but
did you find these?
some of them, not all of them.
I have a question.
Yes.
After you're done on this page, can you go back to the first page? I forgot to write down the first word.
And then pieces.
Also? Never mind, Julie.
Thank you. All right. Again, I'm going to zoom in on the slide here.
Did you find this one?
That one, yes, I did. Okay,
Don't drop it.
so cast is a copy. It's like 3D, it bumps out. Mold is an imprint. So on this side, this is a cast, but on the other side, that is a mold. Okay, what about, which one is a cast, the left or the right?
Right.
Left.
The left.
It's the left. That's not an imprint. This is the imprint. So that's a mold. This is a cast. It looks like it's sticking out. It actually looks like the organism itself.
I got
Wait, what are these?
I'm gonna put it
Those are just types of shells. I don't really know what they are. All right, is this a mold or a cast?
That's a mold.
That's a mold. It's an imprint. Okay. This talon Maybe it's a velociraptor claw. I don't know. Mold or a cast?
Yes.
Cast. Okay. Because it literally looks like the claw itself. The last two types of fossils. Trace fossils and the original material.
I wish those pictures were in the notes.
So trace fossils is the preserved evidence of a living organism. So footprints or tracks in the mud, and then it dries.
What if it doesn't dry?
Well then,
Bigfoot.
well then if it's not preserved, then it's not a fossil. You know what I mean? So it has to be preserved in some way. So we can see that this has been preserved and it's still around. Scat is poop.
Yum.
Okay, fossilized poop. And you can buy scat on eBay.
Yeah.
Yeah, you know what? Here, let me just prove it to you. I'm pretty sure you could probably find dinosaur scat, or I don't know, maybe not dinosaur. Let's just see if what we can find on eBay with scat. eBay scat.
George Washington scat.
Is there a hair on a headrest?
I'm a scat man.
It's called coprolite. That's what dinosaur poop's called. Here we go. Here comes the window.
No!
Ooh, rare lungfish tooth plate and unusual corpulite, which is scat. Big dinosaur. 1837, guys. There's been 12 bids. Got 4 days and 7 hours to bid on it. Ooh, look at this one. Dinosaur dung poo fossil. Okay. Anyways. So, scat nests, as you can see here. So that's evidence of a living organism. These guys were not born yet. So, yeah, trace fossils.
Yeah, look, I got it right. Woolly mammoth. Look at me go.
All right, and then the original material is very, very rare. Like, rare if you find it. The original tissue of an organism is actually preserved. So the woolly mammoths frozen in ice, it didn't break down. You can still see the hair. There's tissues. They've extracted DNA. I don't know if they've sequenced it necessarily,
Are
but
those extinct?
woolly mammoths are extinct, yes.
It's not a thing. I'm trying to bring it back.
I saw a thing
Like
too.
elephants and like
Ostrich egg or something crazy like that.
I'm pretty sure Megalodons are still alive.
I believe it.
Okay, everyone's got the notes?
Mammoth.
Okay, we're going to read out of the book.
That's why I'm never going
And then we're gonna read. And then we're gonna do what you were saying us to do.
Yeah, you know the routine.
Wait, so then do we have to answer the questions?
The 8 questions. They're posted on Google Classroom. Okay, it is on page 89 in your books.
89 or 100?
189. Thank you, Julia. Thank you. And if it's okay with you, I think I'm just gonna read everything because I'm just gonna read it. You don't want me to read?
No, I'm just kidding.
Okay, the fossil record. On your way to school, you might have seen an oak tree or heard a robin. Although these organisms shed leaves or feathers, their characteristics remain the same from day to day. It might seem as if they had been on Earth forever. However, if you were to travel a few million years back in time, you would not see oak trees or robins. You would see different species of trees and birds. This is because species change over time. You might already know that fossils are the remains or evidence of once living organisms. The fossil record is made up of all the fossils ever discovered on Earth. It contains millions of fossils that represent many thousands of species. Most of these species are no longer alive on Earth. The fossil record provides evidence that species have changed over time. Fossils help scientists picture what these species looked like. Figure 1 shows how scientists think that the giant bird Titanus might have looked when it was alive. This image is based on fossils that have been discovered and are represented in the photo on the previous page. So let's just take a look at that guy. Whoa.
He looks like an ostrich, chicken,
Parrot beak. Something.
parrot,
Yeah.
like
Dodo
turkey
bird.
looking thing.
Yeah, maybe. The fossil record is enormous, but it's still incomplete. Scientists think it represents only a small fraction of all the organisms that have ever lived on Earth. All right. fossil formation. If you've ever seen vultures or other animals eating a dead animal, you know they leave little behind. Any soft tissues animals do not eat, bacteria break down. Only the dead animal's hard parts, such as bones, shells, and teeth, remain. In most instances, these hard parts also break down over time. However, under rare conditions, some become fossils. The soft tissues of animals and plants, such as skin, muscles, or leaves, can also become fossils, but these are even more rare. Some of the ways that fossils can form are shown in Table 1, and we'll go through that here shortly. Mineralization. After an organism dies, its body can be buried under mud, sand, or other sediments in a stream or river. If minerals in the water replace the organism's original material and harden into a rock, a fossil forms. This process is called mineralization. Minerals in water also can filter into the small spaces of a dead organism's tissues and become rock. Most mineralized fossils are of shell or bone, but wood can also become a mineralized fossil, as shown in Table 1. So if we take a look at Table 1 here, it says rock-forming minerals like calcium carbonate, basically what shells are made up of. In water, fill in the small spaces in the tissue of these pieces of petrified wood. Water also replaced some of the wood's tissue. Mineralization can preserve the internal structures of an organism. And we saw that with the rings, the preserved, is that the term, the rings?
So it's called
Like the grain of the wood grain. There we go, that's the term I wanted.
So to become a fossil, it would be called mineralization.
That's one way you could become a fossil.
Carbonization is.
Well, that's why we get buried.
What?
And it's carbonization the other one?
Yep, there's 5 of them.
Oh.
Okay, carbonization. In carbonization, a fossil forms when a dead organism is compressed over time and the pressure drives off the organism's liquids and gases. As shown in Table 1, only the carbon outline or film of the organism remains. Fossil films made by carbonization are usually dark brown or black. Fish, insects, and plant leaves, such as this fern frond, are often preserved as carbon films. So, Julia's questioning one of my carbonization fossils. I'm just kidding. Molds and casts. Sometimes when an organism dies, its shell or bone might make an impression in mud or sand. When the sediment hardens, so does the impression. The impression of an organism in a rock is called a mold. Sediments can later fill in the mold and harden to form a cast. A cast is a fossil copy of an organism in a rock. A single organism can form both a mold and a cast, as shown in Table 1. Molds and casts show only external features of an organism. So then down here, that's kind of a bad picture. I don't even know what that is. It's a type of aquatic creature. So when sediments harden around this buried trilobite, I guess I should have just read, a mold formed. Molds are usually of hard parts such as shells or bone. If a mold is later filled with more sediments that harden, the mold can become a cast. Fourth kind is the trace fossil, evidence of an organism's movement or behavior, not just its physical structure. Also can be preserved in rock. Trace fossil is the preserved evidence of the activity of an organism. For example, an organism might walk across mud. The tracks, such as the one shown in Table 1, can fossilize if they are filled with sediment that hardens. So these footprints were made when a dinosaur walked across mud that later hardened. This trace fossil might provide evidence of the speed and weight of a dinosaur. So just by measuring the distance between each footprint, they probably might get an idea too of how long the legs were too.
How much
So
do they weigh?
I don't know. It depends on the species. There's been small little dinosaurs. You've seen Jurassic Park, right? Jurassic World?
Those little ones that when he falls in the little pond that eat him up.
Yeah, they're called the compies. They call them the compies. I think it's the compsognathus.
Wait, so they don't even know the actual names of them?
Oh, they do?
dinosaurs?
Well, they have names for them.
But like, we weren't.
Like what?
We weren't here one day.
No, we weren't.
So they could have been.
So what happened is that they found fossils of these dinosaurs, and then they needed to obviously name them, so then they just gave them names based on either the person that discovered them or characteristics of where they're found. You know, like Tyrannosaurus rex, I think that was like one of the biggest fossils they found, and it means tyrant king or tyrant lizard. So, yeah. All right, and the final fifth fossil, original material. In rare cases, the original tissues of an organism can be preserved. Examples of original material fossils include mammoths frozen in ice, saber-toothed cats preserved in tar pits. Fossilized remains of ancient humans have been found in bogs. Most of these fossils are younger than 10,000 years old. However, the insect encased in amber in Table 1 is millions of years old. Jurassic Park, right? John Hammond and his cane. If you ever looked at the top of his cane,
It's a mosquito.
that's a mosquito. And that's where they got the dinosaur DNA, was insects encased in amber. Scientists also have found original tissue preserved in the bone of a dinosaur that lived 70 million years ago. So, yeah. So it says here, if original tissues of organisms are buried in the absence of oxygen, like ice or tar pits or a bog or amber, they can fossilize. So this poor insect got trapped in tree sap. All right, your assignment is the fossil A questions. You can get most of them from your notes, but some of them you need to use the table.
Isn't that just 5 and 6 on the way bottom?
Yep, 5 and 6 you could definitely just get from the table. 4 and 5 you may need to read the paragraph in mineralization, or maybe parts of it from the table.
What
But
about number 3?
why is it rare for soft tissue to become a fossil?
Because they need the soft tissue.
No. What happens to the soft tissue?
Well, it gets
Or it
replaced
decays.
by minerals.
Nope, that's in mineralization.
It breaks down.
Bacteria
Breaks down. It breaks down, so they either get eaten up by animals or it decomposes before it becomes a fossil.
So we write down.
That's your answer, yes. So either animals eat it or the bacteria break it down before it can become a fossil.